So a little bit about myself. I'm associate professor in civil and environmental engineering departments. I have been working at UCLA since 2016. I introduced this course at UCLA when I joined because this is something also I do for my research. So next couple of slides, I'll show you what I do and how this has contributed to this class syllabus. But first, why do I teach this class? First thing, the research I do, my research is very specialized for this topic. So I'm very passionate about this work, and I continuously update this course with new things that happens in stormwater infrastructures. I am deeply passionate about also sustainability, and I teach 3 courses on that. First one is Introduction to Environmental Engineering and Sustainability. Second one is Sustainable Waste Management, and third one is Green Infrastructures. So you are welcome to check those online and so that you can see if it's something that you are interested. So I wanted to show you what kind of research we do and how this is related. Fundamentally, the science that we work on is subsurface contaminant transport. What that means is subsurface is basically the skin of Earth, where the top few feet of soil layer, which basically filter water, natural stormwater, runoff, everything's, and infiltrate into ground, and which becomes groundwater. So most of our drinking water comes from groundwater, and this is the earth skin that treat that. And so this subsurface also support life form on Earth because it helps grow plants and foods and something that we need. So it's very important to protect that soil layer. And what we do is we engineer that for water treatments and water reuse, which is basically stormwater green infrastructures. My lab name is Subsurface Engineering Analysis Laboratory. There are different kind of work we do, ranging from climate change, how climate change extremes like wildfire affects water quality or water quantity. And then we also use the similar techniques to re-engineer the subsurface soil so that you can remove pollutants or degrade them, which is connected with the groundwater remediations. So there are a wide range of pollutants we looked at, PFAS, microplastic, nutrients, heavy metals. We understand the process, and once we understand the process, we know how to use them for different treatments and different process technology. And so you are welcome to check the website and see if you have any questions, do reach out to me. So what I'm going to show you is that few of those we have presence in Instagram for students to connect with different kind of work we do, and on Facebook. We're not so active on Twitter or Facebook right now, but the most things that we can check on our website. So one of the things that's very important right now, considering we have multiple fires in LA, is that we do research on to understand how wildfire negatively affects the water quality and quantity. And more importantly, how green infrastructures can be used to alleviate the negative effect of wildfires. So in fact, the class project here today, we are going to explain to you is related to that. So do check that out. There are multiple publications from our lab on this, so you can always check on the website. The second thing we work on is how to make these green infrastructures, or if you call it as natural filters, how to improve their self-cleaning ability. Because unlike water filters at home, we can replace the filter once it's exhausted. But in natures, we cannot dig the whole soils and replace that. It's very expensive. So typical lifetime of any green infrastructures is somewhere between 20 to 25 years. So it's very important that we design them to last that long. So this is the research we do on that. One example is that we are also designing green infrastructures to remove emerging pollutants. One of those pollutants is PFAS, microplastics. So we have multiple projects on those. So in class, I'll present those as we discuss different type of design. Overall goal of the work is related to water sustainability. Basically, we are installing a filter on ground that can last forever. That's what the green infrastructure is all about in this class. Also, we are on the side. We also look at how climate change can negatively affect water quality, so that we can design the green infrastructures to alleviate the negative impact of climate change. And in the side, we also looked at how climate change extremes like drying, extreme rainfalls can also affect the green infrastructure functions, so that we can redesign it such a way that we can accommodate those climates and still continue to have the green infrastructure functions. And these particular projects we have from California Department of Transport, Caltrans, where we are redesigning the roadside soil amendment so that the road runoff can naturally be infiltrated into the systems and can be reused, or at least can become more cleaner than what it is right now. The issue here is that the roadside soils are mostly highly compacted. So when the soil is very highly compacted, the runoff always go through the top. So you don't get any treatments, and that means that any pollutants generated in the roadsides or road because of driving and other activities, those pollutants will directly go to the our water bodies and pollute them. So what we are trying to do is replacing this soil with amendments so that despite compaction, the infiltration can happen. So we use different kind of media. So for instance, here ESCS, expanded clay slate clay aggregates, something that we are testing, which increase the capacity, infiltration capacity. So I'll share the results as we see in different lectures. So that's what I explained. Bottom line, if we can rethink how the roads are designed, we can use road infrastructures as a part of solutions for water harvesting technologies. So this is just example what we are doing right now. So this is the pictures to show that the road runoff is coming to these big tanks, and those tank water is delivered to the treatment design that we are testing right now. So the water being delivered on the top, and they will be filtered through the systems and treat a lot of pollutants. Here you can show that some of my students and me compacting the soil so that so that we can simulate the roadside soil environments.